This unit will be on quadratic functions. Quadratic functions are functions that have an exponent. The highest exponent is a 2. And if you see down that picture, it's kind of drawing a U-shaped graph. That's called a parabola. The quadratic parent function is y equals x squared. That's the base function that we will begin to look at different functions to and compare it, whether it's wider, skinnier, if it's shifted up, shifted down. If you notice at this, you're going to find over here, let's see if I can find the mouse over here. You're going to look and you're going to see that you have like 36, 36, where the y numbers are the same, 25, 25, 16, 16, 9, 9, 4, 4, and it all goes, everyone has a pair except for this number right here in the middle. In this case, it's 0, 0, which is right here. That is actually called the vertex. The vertex is the point where the parabola changes direction. When it is down here at the bottom, it's called a minimum. Other ways, it's going to be curved the other way, and if it's up at top, it's a maximum. Okay, so as I press the button again here on this slideshow, you'll see that it has the vertex. Then you've got something in the purple called the axis of symmetry. We'll talk about that in a minute. Then in the blue, that's what I was talking about with those matching up y points. Those are telling you your symmetric points. Now, vertex I already talked about. It's the point where the parabola changes direction. In the purple, the axis of symmetry right here is a line where if you folded the parabola in half, it'd be the same on each side. In this case, it's x equals 0. Well, the axis of symmetry is always x equals whatever the x number is of the vertex. And in this case, it's 0, 0. So the x number is 0. That's why the axis of symmetry is x equals 0. Now, symmetric points. You have 2, 4, and negative 2, 4. Those are them right there. And those are symmetric points. 3, 9 and negative 3, 9, which is right here on our graph. We could also go 4, 16, negative 4, 16, 1, 1, negative 1, 1. Symmetric points. Now on this next one, if you compare it to the parent function, well, what do you see has happened to the vertex? The vertex has actually shifted down 7 units. The coefficient has to do with the width of a parabola. The width is the same. It's still x squared. It's still a 1. The only thing that's different is that constant at the end. And if you look at your symmetric points here, I've got 29, 29, 18, 18. As you keep going up, the only one that does not have another y number is that negative 7. 0, negative 7, when I press it here, will be the vertex. That's that dot down there. Next, you have the axis of symmetry. Now, remember, I said the axis of symmetry is x equals whatever the x number is of the vertex. Right here, x equals 0. Now, symmetric points, where do my y's match up? I've got 1 and negative 6 and negative 1 and negative 6. Those are actually down here. I've got 2, negative 3 and negative 2, negative 3, which are these. And 3, 2 and negative 3, 2. Those are your symmetric points. The only thing that is different in this parabola with the, from the parent function is that it is shifted down 7 units. That's what the minus 7 does. On the next one, that looks all, that's an expanded form than what we may not use here in Algebra 1, at least not for this year. But you can still use the same principles. If I look back through my table over here, okay, I've got 9, 9, 2, 2, negative 3, negative 3, negative 6, negative 6. This is the only one without a symmetric partner point. Negative 2, negative 7. There it is right there. That is going to be my vertex. So as I press the button, my vertex is right there. Now you're going to have your axis of symmetry. This time it's not x equals 0 because my x number of my vertex is negative 2. So I have x equals negative 2. That's my axis of symmetry. That's the purple line. Symmetric points, all we're doing again is matching up those y numbers. So I could have negative 1, negative 6, and negative 3, negative 6. Those aren't labeled on the graph. But then I have 0, negative 3, and negative 4, negative 3, which is these two right here. So all you have to do is look in the table and see where the y numbers are the same. The vocabulary. The vertex is the minimum or the lowest point, or it's the maximum point of a parabola. It's also the point where the parabola changes direction. Axis of symmetry, the line that divides the parabola into two matching halves. It runs through the vertex of the parabola. Symmetric points, pairs of points that are on opposite sides of the parabola. They have the same y values. Quadratic parent function, f of x equals x squared or y equals x squared. This is the simplest quadratic function. The highest exponent again is a 2. Now look at this one. There's a couple things going on. I see that there's a +5. That means that my vertex has moved up 5 units and it starts up here. See, this is a maximum point because see how it's turned down? Now the next thing is the negative is what's making it open downward. If it's positive, it will open upward. If it's negative, it opens downward. Now the coefficient is 1/4. 1/4 is a fraction. I kind of use the analogy that 1/4 is a fraction. It starts with an f. Fat starts with an f. So that means it makes it fatter than the parent function, or wider. Now, if you look over here, I can match up and find the points that match for my symmetric points. Negative 1.25. I've got a 1. I can even go here 4.4. 4.75. The only one that does not match up is 0.5 right here. 0.5 will be my vertex. There it is right there. So my vertex, 0.5. Axis of symmetry. Remember, x equals whatever the x number is of the vertex. X equals 0. Symmetric points, find those numbers that match up in the y column, and those are your symmetric points. Here's another long one. If you look, it's opened downward. Well, look right there. There's a negative. That's what's causing that. Now, up here, if I go and look at my table, negative 138, and I will keep matching up my partners until I find the one that does not. See, as I'm moving, and then I get here, 3.6. 3.6 is going to be my vertex. Now, the axis of symmetry is going to be x equals whatever this x number is. So x equals 3. Then I have my symmetric points. There's lots of them right there. Besides the ones in blue, I could have 6, negative 30, 0, negative 30, as long as the y numbers match up. Okay, from this PowerPoint now, if I go and I look at right here, this is the parent function, y equals x squared. If I take this and I move it up right here, 4 units, I'm going to try and write with this as I do it. In the blue is y equals x squared. That's the parent function. Now what I just did right here in the red, I have y equals, the width is still the same because all I did was shift it up. I just moved it up. So it's still x squared, or a 1 for the width, but it's plus 4 because look, this vertex was shifted up. 1, 2, 3, 4 units. Now I could go, let me get my little clicker here, there we go. Move this down. Now I'll start right there at the parent function. Maybe I just move it down 2 units. All I did was shift it down. The width did not change. You see how it looks like it's a little bit bigger? It's not, because if I move it back up, they're exactly the same. But when I move it down here, it only looks like that because I shifted it down and it's getting wider. This function is y equals x squared minus 2. This last number right here, this constant, means that's where the vertex is as it shifts up and down. My coefficient on all of these is 1. That means that they have the same width. The larger the coefficient, the skinnier the parabola, and we'll show that later. If the coefficient, like that other one I showed in the PowerPoint, if it's a fraction between 0 and 1, that means it's fatter. It will be wider.